So welcome to our webinar. This is the first of two today. This webinar is on CNL's innovative technologies and robotics for facilities decommissioning. My name is Mike Giardini. I'm a communications officer, and I will be the host this morning. First, I'd like to acknowledge that CRL site is located on the unceded and unsurrendered territory of the Algonquin Anishinaabe people. As an organization, CNL recognizes and appreciates Indigenous people's connection to these places. CNL also recognizes the contributions that First Nations, Métis, Inuit, and other Indigenous peoples have made, both in shaping and strengthening these communities where these projects are situated, and to this country as a whole. First off, a few logistical things to note. Today's webinar will be shared two presentations, and we'll open the floor for Q&A at the end, but you can type in questions throughout, and then we'll get to them at the end. There's simultaneous interpretation of this discussion. You can access this session in French through the globe icon on the bottom right on the bar on Zoom. We plan for these presentations to take about 45 minutes and then 15 minutes for Q&A at the end, give or take a few minutes. These sessions will be recorded because we plan to post on YouTube. If you have any issues or would like to chat further outside this technical discussion, please get in touch with us at engage@cnl.ca. Our team will be watching the inbox, so we'll try to get you sorted out. We are also looking to evaluate our webinars more in depth. So following the webinar today, you'll receive an email with a link to complete a short 10-question survey. We'd really appreciate it if you take the time to share your thoughts on our webinars. Okay, today's presenters are Varun Kalra, project lead. He'll be presenting on advanced tech, and Eric Plumley, decommissioning tech, will be presenting on robotics. So let's get started. Varun, whenever you're ready.
All right. Thanks for the introduction, Mike. All right, everyone. Good morning to you. I want to start today by painting a picture for you. Imagine that you are a planner tasked with developing a work plan to decommission a building. Now, as a planner, where would you begin? Oftentimes, one of the first steps any planner takes is visiting the building in question. This is just to kind of get a sense of the structure, assess the potential hazards, and understand the general layout of the building. However, when we talk about nuclear reactors, it means oftentimes contaminated rooms, confined spaces, and areas that are often hazardous for human access. So how do you as a planner approach this task, especially when the blueprints are outdated and no longer reflect the current state of the building? This is where my team, the innovation team, comes in. And we create a digital replica of the building, allowing you to conduct a virtual walkthrough from the safety of your computer. With this digital replica, you can access, analyze, and make informed decisions without ever stepping foot inside the building. Next slide. So what you're seeing here is an example of a digital visualization of our NRX reactor. This reactor started operation in 1947 and was shut down in 1993. Currently, it is being decommissioned. A digital visualization, just like this one, is created by laser scanning buildings and then processing that data to create this output. And we can also visualize the internal components of the reactor that are not accessible to the naked eye, just like what you're seeing here in this short video. So over the last 1 year or so at our Chalk River site, we have completed and published 20 building scans just like this one for both indoors and outdoors locations. And additionally, we do support our offsite locations such as Douglas Point and Gently One. Moving on to the next slide. So talking about the why behind digital visualization and a little bit of its benefits. Initially, the development of digital visualization was driven by the need to adapt to work from home arrangements due to the challenges posed by COVID-19. to ensure the continuation of essential decommissioning and environmental remediation efforts. But today, the innovations team capabilities have matured, leading to several inconceivable benefits, such as improved safety, stakeholder engagement, ALARA, which stands for as low as reasonably achievable exposure to radiation, um, then data visualization and risk mitigation. All of these benefits leading to safe and efficient workflow. Although our focus is on improved safety, but digital visualization helps to attain passive monetary benefits by the means of error avoidance as well. Now, I want to highlight the one key rule here, which is the 1-10-100 rule, which states that prevention of an error is cheaper than its correction, which is further cheaper than the cost of a failure when you are executing decommissioning processes. And this elaborates how the cost ends up scaling exponentially through the process life cycle of decommissioning a building. And so we come in the initial stages and try to reduce the cost aspect as well as improving safety for our field techs. Moving on to the next slide. So along with the geometric digital visualization, as you saw earlier for NRX, we also have the capability to develop gamma radiation visualization. This allows us to take the digital visualization to a whole new level. Gamma radiation is invisible to naked eye, as most of us know, and we use special equipments to help us visualize and map the radiation sources as heat maps that you are seeing over here. These gamma radiation visualizations enrich planning and help us to identify sample procurement areas for material characterization studies and so on and so forth. So on your screen there, what you're seeing are two different projects. On the left side, that is a heat map that our team created for our Douglas Point reactor, just a room with visualizing how the gamma radiation spreads around in that visualization. And on the right side, you see a study that was done on the NRU evaporator room to understand the effectiveness of an ultrasonic cleanup method on this evaporator, and see how that ultrasonic cleaning can shift or displace this hotspot that was there on the pipes. So you see a pre and post comparison of an ultrasonic cleanup, which would be difficult to really visualize or understand or get a sense of with traditional equipment. So that is where we add most of our value. Moving on to the next slide. Now, along with radiation visualization and um, general scanning and laser scanning, we also support our environmental remediation teams and our other field techs by the means of commissioning robots, different robots. Um, Now, what you're seeing here are two quadruped robots, in other words, robot dogs. Um, on the left side, the robot you're seeing is called Remediation Rex. This was commissioned to support environmental remediation by mitigating hazards faced by surveyors, including, for example, tripping hazard, exposure to poison ivy, and poisonous ticks, and so on and so forth. Over the last 1 year or so, we completed the commissioning of this robot and um, sorted out issues and initial glitches that we faced during the deployment of this dog. Right now, it is at a stage where it is actively being deployed on numerous remediation sites at Chalk River. On the right side, you're seeing another quadruped robot dog that helps us reduce hazard exposure while capturing laser scans for our digital visualization efforts, especially in the confined spaces. So instead of sending a person to capture all of those laser scans, now we can send in this robot dog with the scanner mounted on top of its back, as you're seeing, and it can capture all of the scans to help us visualize the area in question much better. A couple of places where we deployed this dog over the last 1 year or so was in NPD and also in the NRU steam tunnel, which is where we performed a drone project, which I'll be speaking towards in our next slide. So moving on to the next slide now. So over here, I'll talk about the two drone projects that our team worked on. But before that, let me just give you a little bit of a brief history of these two projects and the procurement of the drone. So about 9 months ago, we procured the drones to facilitate our work planning in hard to access indoors kind of environment. Subsequently, we acquired the necessary training from our internal group, like the mechanical equipment design group, and externally by acquiring drone piloting certificates. As shown in the video on the top right, this was a mission to identify a defective steam valve in the NRU steam tunnel, which is inaccessible to people due to safety hazards like falling debris from the roof of the tunnel. And the drone was chosen for this task as a viable substitute. And we completed this mission successfully. So the valve in question is actually at the end of the tunnel. On the top right video, and soon you will be able to see uh, the defective component that was then recognized and replaced by our infrastructure team after we perform this mission safely. So this is the valve in question right there. And you're seeing the capability of the drone to actually take the thermal image as well as record all of the details of the valve, the part specification, and get a sense of the adjacent areas so that the planning team can plan the installation of a replacement component uh, in this tricky situation. Um, and on the bottom, there is another video, which I believe we can play now. Um, so that shows the same drone deployed in the building 204, that is rod based, to inspect the coverage of a spray-on liner on the walls and capturing radiation dose to support future waste estimation planning. So the drone does have the capability of capturing radiation dose by approved um, detectors. The mission was completed in 2 hours, and it helped offset approximately 1700 millirem of collective dose, which is equivalent to over 30% of allowable annual dose limit for a nuclear energy worker. So just speaking about ALARA there, as low as reasonably achievable, these equipments oftentimes they seem very valuable in terms of reducing exposure to our workers. And with that being said, we can move on to the next slide. So with all of this data collected, we had an issue um, and a challenge to actually manage all of this large amount of data. And that is where our system, our point cloud asset management system, which is called PCAM, that comes in order to just manage with relative ease and revision control our data. So what PCAM does is it is a platform that serves as a front-end user interface for all our scanning projects. And it offers, as I said, revision control, access control, password controls, and things like that to just better manage our digital twin data. Over the last 1 year or so, we have consistently developed this platform, improving data sharing capabilities, improving the reporting capabilities, which basically tells us how the adoption of digital twin is moving along and establishing KPIs and tracking them from an year-to-year basis, and overall improving the life cycle of our digital twin. So with that being said, I think we can move on to the next slide, which brings us to the end of my presentation here. And with this, I transfer the mic over to my colleague, Eric, to take the webinar along to the next stage. And I thank you for your attention.
Thank you very much. Like you said, my name is Eric Plumley. I am part of the facilities decommissioning side. Thank you very much. We do projects on CRL site as well as Douglas Point and Whiteshell. We use this technology as much as we can. If we can go to the first slide, we'll just jump right into the technology. It'll just be a brief overview, and then if you have any questions, we can go into more depth at the end. So this is the first unit on my slide. It's the Braun wall shaver. So the Braun wall shaver is a revolutionary tool for precision shaving of walls for construction sites and renovation projects. So it's essentially a CNC machine for the wall. So it allows you to control the depths within a millimeter, all remotely. So keeping the worker safe and in a different area than the tool. The ergonomic design, powerful motor ensures smooth, efficient operation, reducing both time and effort required for wall preparation. So what we use this for on site is to remove surface contamination, specifically in the 200 series buildings here at CRL site. This has been successfully used for the entire second floor of the 200 series, as well as now the first floor. We can go to the next slide. So this is it in deployment. You can see how it's shaving the walls. Again, this is fully remote. It has a vacuum dust suppression system to collect all of the debris that comes off of it. Next slide. So the next we have our blocks. So these blocks are electronic. It's a series of remote controlled demolition robots that revolutionize the way we approach heavy duty tasks. These compact yet powerful machines can access confined spaces, hazardous environments, making them ideal for demolition, excavation, and maintenance projects. So they're very versatile. You can put hundreds of different attachments on it, depending on our needs. Specifically on site, we've used them in 200 series with a planer attachment. We've also used them for building 440 for debris cleanup. We've actually demoed small buildings with the bigger units where it was dangerous for an operator in a typical excavator to be in. Next slide. Next, we have the M25 spray trailer. Here you can see on the photos from left to right, we've designed it to be compatible with the Brock. This will allow us to go into confined space and to spray the M25. Basically, it is a gray coal sprayer. The best I can describe it is like truck bed liner that you would see in a typical pickup truck. Except for this M25 is rated for nuclear applications. So it's just a little bit stronger. It uses an elite propulsion system. It basically sprays down a filament of flexible rubber, ultimately making a seal, a watertight seal. This is ideal for sealing sea containers on site. We've used it in the 200 series A bays that you previously saw from the presentation before. We use the M25 for sealing roofs, for, like I said, sea cans, as well as bays, foundations. It's a quite versatile application. Next slide. Here is the unit that I just spoke about, the M25. So it's a two-part polyurethane, and this machine sprays it out at about 2000 psi, which then atomizes the two solvents together, ultimately creating the rubber barrier that we desire. This barrier is rated for 25 years out in the sunlight. Next slide. Next, we have the Hilti wall saw. The Hilti wall saw is another innovation that streamlines cutting and demolition processes in construction and renovation projects. You can see on the first photo on your left, it is completely hands-free. This allows the operator to be back in a safe environment, out of the elements. The second slide on your right, you can see the blades. They come in various sizes up to a 6-foot blade. So you can use this for a lot of applications depending on how deep you have to cut. You use a different blade. The ergonomic design integrated dust extraction system enhances operator comfort and safety, making it a preferred choice for professionals worldwide, as well as us on site. On site, we've used this for building 440 demo. We will be using it for the catwalk and many more. Next slide. These are another couple photos kind of giving you a better idea of the versatility of the Hilti wall saw and how compact it is. Really, really sleek design. Our departments relied on it heavily in the last couple months for our demolition needs. Next slide. Next, we have the Hilti load balancer. The Hilti load balancer is a safety device designed to prevent accidents and injuries from falling objects on construction sites. Basically holds the tool for you, takes the weight off of your arms and puts it into your core. This allows the worker to work longer, safer, and prevent injuries. Next slide. Here's on the job. You can see the top left photo. You can see effectively the tool is taking 100% of the load, and the worker just has to run the trigger. We use these in 200 series for the concrete remediation, where the brawn can't get into the corners. We will then send a worker in. And then this was utilized to hold the grinder while they get into the hard to reach areas. It was deemed extremely beneficial as it reduced all the injuries. As the grinders for concrete are quite heavy, this limited that factor. Next slide. Next, we have the Creaform GoScan scanner from Creaform. In simple terms, it takes photos of 3D objects and allows us to put it into software on the desktop, which will then, we can save it as information for later, or we can then modify the 3D item. Next slide. Here's the brief photo of it. So it has the handheld device. It has multiple cameras grabbing photos throughout the scan process. As it's scanning, it will show everything on the laptop. It distributes 99 bright lights, stripes, 1.5 million measurements per second. And this device accuracy to the item is 0.050 of a millimeter. So this ultimately allows us to re-engineer items that have been previously designed or constructed. We use this in NRX and NRU on our legacy tooling, tooling that was designed specifically for our reactor on site. They are one of a kind. You can't get these off the shelf. So this allows us to save this legacy tooling so the technology is not lost. Next slide. Next, we have our 3D printing capabilities. Most specific, this one is our Big Rep 1. So the difference with this printer is it's 1 cubic meter build volume. So it allows us for prototyping, production, and a wide range of applications. The Big Rep 1 comes equipped with big fiber ready power extruder that ensures interchangeable 0.6, 0.1, 2.0 millimeter nozzles for maximum detail and high flow additives manufacturing. If we go to the next slide, you can see a photo. Here you have the photo in the center, the big yellow orange square, sorry. You can see a couple items around the center photo. So top left is a dust suppression for our local carpenters on site. This allowed us to mitigate dust being inhaled into the worker. This can specifically only be printed out of this unit as it requires the 1 meter square bed. So we use this on site for multiple applications, a lot of prototyping, proof of concept for new tooling that we're going to design for specific projects here at CRL, as well as Whiteshell and Douglas Point. We utilize these printers on a daily basis. Next slide. And that would come to the end of my presentation. In conclusion, the advance and construction of maintenance equipment showcased today are revolutionizing the industry, enhancing efficiency and precision and safety. By enhancing these cutting-edge tools and technologies, professionals can tackle tasks more effectively, delivering superior results in less time and fewer resources. Thank you for your attention. I'll hand it back over to Michael.
Okay, great. Thank you, Eric and Varun. Great presentations, very interesting. A lot there, but you guys explained some complicated subjects very well. Okay, so time for questions. We are right at the half-hour mark, so good timing. So again, you can type your questions in the Q&A function on the screen, and we'll just wait a sec to see a couple come in. Okay. Okay, the first question is the goal of the bronze shaver to make the concrete clearable? That be for Eric, I believe.
Yeah, thank you for the question. The goal for the bronze shaver is to shave the surface contamination of the interior of the building to ultimately bring the overall level of contamination for the building as a whole to an allowable limit to then demo the entire structure. So the goal is to send it in and to effectively and quickly shave large amounts of space and only taking less than an inch from the wall, which is typically where 99% of the contamination would lay. So that's ultimately what the goal was for the shaver.
Okay, great. Thank you. Thanks. Next question is wondering what your team's biggest challenge was in deploying digital visualization and how you overcame them.
So I can take that.
Okay.
So on the technical front, the biggest challenge I believe is overcoming security considerations and information asset protection considerations. Initially, when we were looking into multiple different platforms, multiple different software and hardware, we overcame these by creating an on-premise hardware setup for us in order to control our data in-house in accordance with our IT team's preferences, and on the information asset protection, just kind of collaborating with the security teams to make sure that we label all of our digital twin data correctly. If something is is requiring an additional level of clearance, then we account for that through proper data sharing and data governance practices. So technically, I would say those are the challenges, and solution-wise, the solution came through collaborating and through having a back and forth conversation internally with a bunch of different teams to find out a best way to implement this. But functionally, I would say the biggest challenge we faced was the adoption of digital twin itself. And we looked into kind of, um, you know, mitigating that challenge was by creating case studies, by proving before we had any quantitative substantial data on how much it helps to improve the overall workflow for our planners and for our field techs. Before we had any of that quantitative data, it was hard to actually prove the use case. So we did that by creating case studies, by creating articles by showcasing, how small um, changes in the way you visualize things through the digital means can make big difference downstream, just qualitatively speaking, and getting that buy-in slowly and gradually um, developing on that front. I
Okay,
hope
great.
that
Thank
answers
you.
the question.
Thank you for the answer. Let's continue on. How do you maintain and troubleshoot drones and other tech to ensure they remain operational? Oh, so David's going to answer this question. David, if you
Yep.
can just quickly introduce yourself.
Hi, I'm David. I'm one of the decommissioning technologists on the innovations team, and I'm primarily responsible for the drones and other robotics that we have. So in terms of maintenance, there is regularly scheduled maintenance that we conduct for drones, such as physical inspection of the cage, inspections on the motors or props, as well as monitoring the battery system to make sure that that stays in a healthy state. Um, you might be worried that, oh, we're sending these into highly contaminated areas. Anytime that it comes out, so far it's been clean, but we would be, if it was contaminated, we could use a fume hood or something of that sort to clean it up and fix it and then redeploy it into the field.
Okay, great. Thank you. That answered another question. So about decontaminating tools. So we'll continue on. Here. All right, good questions coming in. Will you be adding gamma spec instrumentation to the robotic platforms?
So I can answer this one again. So we currently have a gamma spectrometer on remediation Rex. It is a pretty standard 3x3 gamma spectrometer. We do have some gamma imagers, which we will be deploying on the robotic platforms. In the future, we're still investigating that, but should be coming up in the next year or so.
Okay, great. Thank you. Okay, moving on. We'll give David a break here. We'll go back to Eric. And this question is, what depth can the bronze shaver shave off in a single pass? And what depth is required to reach the desired results in your situation?
Yeah, thank you. So the maximum allowable that it will do is a 1/2 inch. We've been running it at a 1/4 inch, but the desired depth is based off of the contamination level in each specific wall. So for the 200 series, we had documentation from the engineers to not surpass an inch, and then we don't have any structural issues with the building. Typically for our application in 200 series, we never had to go deeper than a 1/4 on the walls, and that got 100% of the contamination removed from the walls. Thank you.
Okay, great. Thank you, Eric. Okay. Seeing what questions we have left here. What materials do you print most of the time, and what can you print on? Okay, what can you print in? Sorry.
Yeah, I can answer that one. We do a lot of printing for our mock-ups are usually with PLA, very basic plastic. When we get into manufacturing stuff for the field, we can actually utilize carbon fiber inlay as well as PETG. But we are capable here at CNL in printing with all filaments that are available to date in the industry. Most recently, we are getting set up. We're in the trial phases of printing tungsten infused PLA. This will allow us to create customized shielding for technologies to go into high level fields of radiation that typically causes havoc to technology. This will allow us to prolong our technology in those high dose areas. Thank you.
Okay, thanks, Eric. Okay. We can get to a few more here. How communication work between advanced tech and their operators?
I can field that question for the robotics that we use. So the drone uses a pretty standard radio frequency link. I think it's either 2.4 or 5 gigahertz. Some of the other robots, such as the robot dog, will use Wi-Fi, but we also have Wi-Fi Halo, which is like a very, very long range version of Wi-Fi because it operates at like a sub-gigahertz level. And for other things, we'll use a wired tether if we can't get radio frequency through whatever shielding is there.
Okay, thank you, David. Okay. Just double checking. Okay. Have there been issues with the utilization / selection of new technologies in relation to associated commercial softwares and IT security?
So I can try to answer that question. First of all, I would not say issues, but at the same time, we need to be mindful that we, as a people in as a company in nuclear industry, we are faced with regulatory considerations. We have strict protocols and procedures and IT requirements that often need to be met when it comes to onboarding new hardware or software, um, and that can take time and effort to get across. Along with that, there are, as I mentioned initially, some considerations on the you know on the type of or like, for example, hosting software on cloud versus hosting on premise is one of the consideration I can give you an example of. So on cloud, is something that uh, we do not do for most of our digital twin efforts, mainly because of the data associated risks that come along with the places where the data would be hosted. And so similarly, there are many software right now in the realm of innovation that are actually on cloud. So that is one consideration that, for example, restricts us from adopting new software technology, and that has to go through a proper, a long cloud evaluation for risks and understanding of how the data is being used or where it is hosted and all of that. So that's just one example. But then there are many other considerations that we have to keep in mind when we talk about onboarding new technology. And we do our best to keep everyone at CNL, including IT, including other stakeholders, happy. to proceed forward as we push our frontiers in the realm of innovation.
Couldn't find the mute button. Thank you, Varun, for that answer. Okay, moving on. What kind of training is required to operate these kind of tools? Whoever wants to take that one. As there's several tools we talked about, but I see David's off mute. Okay,
Yeah.
thank you.
If it comes to the drone, then if you're operating it inside, you just have to be proficient in operating a drone, as well as have the manufacturer's training. If you're operating a drone outside, because all nuclear sites are pretty much restricted airspace, as well as you're using the drone for a commercial purpose, you'd need to have your advanced UAV license from the, I think it's Transport Canada. For the robot dog, that's again just vendor training, things like that, which they offer when they sell that to you.
Okay, thank you. How is the gamma source mapping combined with the 3D scans being leveraged by your HP/work planners for work protection?
So the gamma imagers will typically be used by characterization officers to identify sample locations. Other instruments will measure dose at a specific point, which those can be used for dose commitment predictions. But yes, the largest purpose is for general awareness. A lot of the times, the places where we do this imaging are for rooms that are hard to access or do have like a high dose field in them. So you'd want to check that before you send someone in so that they have an idea what they're walking into when they enter the facility.
Okay, great, thank you. Okay, we're nearing the end of our questions. Yeah, okay, we'll get to one more. And it is, okay, yes, last question. How are you planning to manage obsolescence of the devices you've shown, particularly robotics?
So I can try to answer that like from a functional standpoint, and maybe then David can later on pitch in from a technical standpoint. We do have our product development pipeline plan created for the next 3 to 4 years. In that, we have some equipments that will be upgraded. Obviously, it comes to speaking with our vendors and understanding what their plans are when it comes to improving the features the equipments have to offer us. But then there are circumstances where, for instance, we have computers and other hardware that generally degrade over time, and we kind of budget for that. We keep an eye out for the new technology that is surpassing our current, current, for example, just gamma radiation visualization equipment that we are using. We are keeping an eye out right now for what is out there, what is being developed, just going to the conferences and talking to other vendors and seeing how the technology in the industry is being developed, as well as how the peers are starting to use this technology to get a sense of what is the growth trajectory for each and every equipment from a vendor standpoint. And then we change our, or we try to align our product development pipeline in accordance with that, as well as our product development pipeline is dependent on our internal use cases. So that also kind of has its own trajectory of development. So we do try to kind of synchronize both of those two together. And oftentimes what we see is some really old robots, on, yeah, I guess like Ross one, and I think David can talk more about those technologies. Like those kind of old technologies have to be slowly phased out, and then we figure out if there are some other teams at CNL who need that robot. We try to transfer it over to them, or we, just salvage that, and we look at other ways of just improving on our workflow um, in accordance with those considerations.
Yeah, go
And
ahead,
then-
David.
And then from a technical standpoint, if it has to do with software, we'll either try and keep something locked to a specific version so we don't have to worry about it being updated and becoming incompatible. But yes, for hardware, you do have to keep an eye on what the industry is doing. And before you purchase something, make sure that the development path for that product is going the direction that will be useful for whatever task you need it to do.
Okay, great. Thank you, guys, for those answers. Varun, Eric, David, thank you for answering those questions and doing those presentations. Very exciting stuff that you're doing. I'm glad we were able to share that with the public today. Before we wrap up this morning, I'd like to encourage everyone to please take the time to complete our follow-up survey that we'll be sending out to you shortly. We'll send out the links to the recordings once they're posted on YouTube, and feel free to distribute those links to anyone that might be interested. We will also include responses to any questions we didn't get to this morning. Remember, you could always reach out to us at engage@cnl.ca. We also have a second webinar coming up in 10 minutes on White Shell Laboratories, environmental protection and site relicensing. So once again, thank you all for attending, and thanks my comms team for behind the scenes work, and we might see you in 10 minutes, or we'll see you next time. Thank you.